The history of using oneself as a test subject has a long and illustrious history in the annals of science. To add to this body of N of 1 research, I've designed, run, analysed and critiqued a skill acquisition training program for a novice harmonica player. The aim of this training program is not to learn only one song, but rather to learn the instrument in such a way that it sets up the learner for long-term learning. That is, being able to play a variety of songs in different settings. The harmonica, aka harp, is a musical instrument which is played by coordinating the lips, tongue, hands and head with the player's breathing such that air is moved through holes along the length of the instrument, holes which direct the air such that it passes over reeds which vibrate, producing a tone. Harps commonly have 10 holes, with each hole capable of producing at least 2 notes, a blow and a draw note. Harps are complex, capable of producing many more than merely 20 notes. Techniques like slides and bends are analogous to bending strings on a guitar. They greatly increase the number of notes it is possible to produce. A diatonic C-tuned harp was used for this program. The training program's design is based upon fundamental principles of the constraints-led approach to skill acquisition. The foundation principle of the CLA is moving from a reductionist analytical perspective to a synthetical systems-based approach. The learner themselves is a complex dynamic system, as is the instrument to be learned and the environment in which the learning is to take place. Likewise, these three complex systems themselves are components, entities of a larger complex system. This larger system I will refer to as the primary reference frame. Primary in that the learner's acquisition of and ability to acquire and demonstrate skill is best understood when considering these entities as a part of the greater whole. Reductionist subdivision may be necessary for analysis of each entity, but it is important to note that when decisions are made, the whole primary reference frame must be considered. The next fundamental principle of the CLA is this. It is in the act of attempting different strategies that the learner illuminates the landscape of possibilities. Recall the primary reference frame. The learner, environment, and task are linked. But how? By energy flowing between them. Known as the perception-action coupling, Gibson's seminal 1979 work proposed that it is not possible for the learner to perceive the environment or the task without acting. To perceive, we intentionally admit energy flows from the environment and task. And to act, it is necessary to perceive the constraints afforded by the environment and task. By analogy, imagine 4 scenarios of being lost in a cave and trying to escape, with and without a torch, and sitting still or moving around. With no torch and no movement, nothing interesting will happen. With a torch and no movement, only a limited local area is uncovered, but nothing more. With movement and no torch, discovery is random and totally disorganized. But with both movement and a torch, the whole cave is able to be investigated and an escape route found. Both are necessary to achieve the goal of getting out of the cave. Nonlinear pedagogy promoted by the CLA encourages the learner to explore, discover, succeed, and fail throughout the learning process. A coach cannot know beforehand the optimal strategy for this complex triumvirate of learner, task, and environment. Rather, it is in the process of attempting strategies, succeeding, failing, attempting again, an iterative process in which the learner will gradually discover their favored strategy. If a strategy is instead imposed authoritatively, it may not be suited to this learner, slowing the learning process. This approach requires the coach to understand that the learner will go through periods of performance variability. That is, they will not always get better from one moment to the next, but over longer time scales, they will. To extend my cave analogy, it is the coach's job to make a cave that is neither trivially easy nor impossibly hard. Coaching using a nonlinear pedagogical framework means creating a cave which the learner will both want to and be challenged but able to explore. It may mean the learner will wander in a direction away from the cave exit, but the coach must trust the learner will recognize and learn from this indirect escape route. This is the basis of the nonlinear pedagogical approach. Rather than imposing techniques, directly telling the learner how to achieve the task goal, it is the coach's job to provide an environment in which the learner can find, for themselves, a way of achieving the task goal, understanding that degradations in performance are temporary and necessary paths towards improved performance. Nonlinearity does not imply that there is no structure to learner progression. Newell's 3-stage model for motor learning supplies the framework upon which stages of learning can be based. In Newell's model, the first stage of learning consists of coordinating basic relationships among motor system components. This allows for the next stage. These components are now beginning to be controlled, allowing increased task outcome consistency despite changing performance environments. Finally, as these control patterns are further developed, they are optimized for efficiency. This is stage 3. It is important to note that each system component can go back and forth between these stages independently, all of which affect the primary reference frame and which stage it is in. The ideal coach would, by observing the entire primary reference frame, identify and manipulate constraints which support and motivate the learner's exploration of the perceptual modal landscape, allowing them to identify, interact with, and exploit constraints as they are discovered. In doing so, the learner and their associated sub and supra systems will, over many attempts and iterations, self-organize on many different levels, moving between different stable, functional coordination states, attractor states. Given time, the learner will gain control over these coordinative structures and then become more efficient with them. Noticing this, the coach can then alter constraints upon the primary reference frame, perturbing the learner's attractor state. The process starts again. The learner self-organizes under this new set of constraints, widening their attractor base. They are now able to perform efficiently in the old domain and this new one. This is the path to skill acquisition using the CLA. The CLA, at its systems-based paradigm of skill acquisition, is built upon the foundation of earlier theories of skill acquisition. Fitt's framework identified that learners will move through different stages on their way to acquiring skill. However, it placed too large an emphasis on the need for the learner to cognitively grasp the task at hand and is only applicable in specific circumstances. Schmidt's schema theory of generalized motor programs is a product of its time. Mid-20th century psychomedical research was incorporating early 20th century computer science and in many ways was attempting to make human behavior understandable in that context. It cannot integrate the concept of direct perception and instead attempts to relate human cognition to that of their contemporaneous computers. Interestingly enough, the cutting edge of computer science is now coming to utilize the perception-action coupling when teaching neural networks. Practice is split into two categories, deliberate and play. Deliberate practice consists of 30-minute sessions, seated at a desk, engaging with expert harmonica demonstration in the form of online harmonica tutorial videos. Completing a session is noted. This allows for the tracking of time played. Play practice is that which is able to be performed throughout the day at any opportunity, while at a traffic light, while in between sets of a workout, things like this. The size of the harmonica is a positive task constraint in this sense. It is highly portable. There is no set duration for play practice, nor are there any specific goals other than accrue time playing the harp and experiment with what is learned during deliberate practice. Estimate the time spent performing play practice at the end of the day. This time is then recorded. The rationale for splitting practice in this way is that coordinative structures which are established during deliberate practice can then be perturbed by varying environmental constraints during play practice. This variability allows for the acquisition of more stable coordinative structures, resulting in less variable performance. For 9 weeks, perform 3 30-minute deliberate practice sessions and at least 45 minutes of play practice per week. This will result in about 20 hours over the 9 weeks. A 3x10 whole blow test for time, 10 HBT, was chosen as a suitable assessment of skill acquisition. Starting on the 1 hole and individually moving up to the 10, reversing and then once again from 1 to 10 was decided upon as the gold standard. This tests accuracy of hand, lip, tongue, and breath coordination along the whole length of the harp while involving a time constraint. The coordination of body, breath, and instrument is fundamental to the performance of any wind instrument, thus a decreased time on this test indicates the acquisition of skill. This test is performed immediately following the 3rd deliberate practice session of a given week and at the learner's discretion during play practice. A transfer test is conducted 3 times, at the commencement of the program, at the end of stage 1, and at the end of stage 2. This test is a reverse 10 HBT at a pace set by a metronome, 50 beats per minute for the first test, 65 for the second, and 80 for the third. This is to test if intrinsic dynamics are stable enough to accommodate new task constraints, keeping time, and starting on high notes. 10 attempts are allowed per test. If any mistakes are made, then the attempt is a failure. If after 10 attempts, no successful attempts are achieved, no time is recorded. If multiple successful attempts are achieved, the best time is recorded. Sign up for and use the expert demonstration provided by this link during deliberate practice. Using expert demonstration during deliberate practice affords the opportunity to identify constraints. During play practice, experiment with the harp. Do not take the instructional videos as gospel. Explore different ways of achieving the basics of harp playing and don't be afraid to make mistakes. Attempt the 10 HBT as often as desired. Progression criteria is the ability to achieve a 10 HBT time of less than 20 seconds in 3 different environments. This stability of performance in varying environments implies basic functional relationships between system components has been established. During this stage, the first deliberate practice session of a given week is for basic technique. The following deliberate practice sessions are 10 minutes of technique, followed by 20 minutes of song practice. For the song practice, find and play along with songs by listening to, reading tab, or following along with a demonstration of a song. Self-select songs by searching diatonic C harp songs or tab on YouTube. Select one beginner song per week. Practice it at a self-selected tempo until it can be played without errors before moving on to another song. During play, continue to experiment with the basics while exploring the melodious components learned during deliberate practice. The progression criteria from this stage is achieving a sub 15-second 10 HBT in 3 environments and being able to play When the Saints or a similar beginner's song at the learner's own tempo. Deliberate practice sessions now consist of 10 minutes of basic technique practice, with the remaining 20 minutes for song practice. During this stage, focus on how timbre and tempo are controlled. At first, utilize familiar songs learned in stage 2. Focus on optimizing them before moving on to new, more challenging songs. When optimizing songs, do not simply practice 1 or 2 challenging bars over and over, rather slow the whole song or phrase down so that the performance is accurate, then slowly build up speed again. During practice, continue to experiment and accrue time playing melodies. Try different ways of performing the familiar songs. Experiment with techniques that have been learned. Exit criteria from stage 3 does not make much sense. However, continued skill acquisition at this point in the program can still be assessed. Successful completion of this 20-hour program is a sub 10-second 10 HBT time in 3 environments, and being able to play along with famous recordings of songs while maintaining a subjectively good timbre. This program was not completed by the participant, me. I did not accrue 2.5 hours per week, in total only accruing approximately 11 hours of playing over the 9 weeks. These 11 hours were not accrued consistently, and so at no point was I able to satisfy the progression criteria of stage 1. Due to this, only 1 transfer test was performed. Additionally, using video to compare playing before the program and playing now, little change has occurred in my timbre. While this program was based upon the CLA and integrated many of its elements into its design, it did not provide an environment that was motivating for the learner, or rather it was undertaken during a uniquely demotivational time for this particular learner, while in lockdown due to a pandemic. Radically new, unplanned environmental constraints were discovered. These combined to create an environment in which negative thought patterns readily appeared and propagated. As such, environmental and organismic constraints undoubtedly played a sizable role in determining this outcome. In particular, the organism's motivation was this program's single point of failure. Additionally, the program fell prey to the planning fallacy. This program assumed that 2.5 hours of practice would be obtained each week. It had no backups or incentive structure that would encourage the learner to attain these hours. This is a clear limitation of the program. However, as this program did not prescribe set times or dates for each stage, fully in line with the nonlinear approach, I argue that this program is not a failure, rather, it is ongoing. The program's fundamental basis in the CLA is its main strength. Every design decision of this program was based on a synthetical understanding of the primary reference frame and the constraints which act upon it. Further, as the program uses a standard test over its whole course, it can be started again with the 10 HBT used as a diagnostic device, helping to assess which stage the learner should proceed from. This skill acquisition program was not completed in the time allowed by the circumstances in which it was undertaken. I did not accrue the 20 hours prescribed in the 9 weeks as planned, and therefore cannot judge whether the program would have been successful if it was run as prescribed. Judging it as it was run, the program did not foster a motivational environment for the learner, which was further impacted by worldwide negative environmental constraints. Together, these environmental constraints affected organismic constraints in an unexpected manner. Organismic motivation was the program's single point of failure and was not accounted for in its design. In future iterations of skill acquisition program design, I will be much more attentive to the motivational incentives of the program which I am designing, and I will put in place backup plans which can mitigate external negative environmental constraints. Further, I will take time to identify single points of failure and make design decisions to mitigate their impact. This was an interesting project to undertake. It provided me with a first-hand example of the planning fallacy in action and the need to carefully account for all constraints in program design. I'll end by quoting Gall's law from his Systems Bible. A complex system designed from scratch never works and cannot be made to work. You have to start over, beginning with a working simple system.